Hello, folks. Started a bit of blatant advertising for you. So if you don't know, we're running the Exeter Climate Forum this first week of July. Still sign up for both these conferences, Global 2 Points Conference, Exeter Climate Conference, online through those weird things. So please do. It's going to be a great event. And I'm going to hand over to a great event now, to Michael and to Pierre.
Thanks, Peter. So hi guys. It's a great pleasure to have Michael Mann with us today. So briefly, in a nutshell, I mean, Michael is, I would read my notes, presidential distinguished professor in the Department of Earth and Environmental Science at the University of Pennsylvania. He's also the vice provost for climate science and policy and action at the university. He's got an undergraduate degree in physics at University of California, Berkeley. Then he moved to Yale for a PhD. And his research interest is mainly on the study of the Earth climate system, science, impact, and policy implication. And Mike is well known for the hockey sticks. He's the brain behind the hockey sticks, which I'm sure you will see a figure of the hockey sticks. And it's one of the most iconic figures from the IPCC. If I had to name three figures, it would be one of the three. Don't ask me what are the other two. I don't know, but he's one of the three. He was immediately loved by all the climate scientists, immediately hated by all the climate skeptics. And so he contributed to IPCC on the third assessment and onward. There's a long list of awards that he received over his career. Hans Hösger Medal for the EGU, the Friend of the Planet Award from the National Center for Science Education. He's got awards in science and also in communication. There's Stephen Schneider Award for outstanding climate science communication, award for public engagement with science, the Climate Tyler Prize Award, which is a bit like a Nobel Prize for the climate scientists, and so on. He's a member of U.S. National Academy of Science, for a foreign member of the World Society, elected last year. He also was one of the co-founder of Real Climate with Kevin Smith, I think. And he's written loads of papers, about 300, according to my notes, and books as well, including the latest one that he will kind of present today, I think, which is called All Fragile Moments, Our Lesson from Earth Past Can Help Us Survive the Climate Crisis. Mike, it's a great honor again to have you with us in Exeter. The floor is yours.
Thanks for the, let me make sure we've got, oh, there we go. Okay, good. Well, thanks so much for the kind words, Pierre. It's great to be here. I have so many friends and colleagues in the audience. I can't believe this is the first time I've ever made it to the University of Exeter. So it's a real pleasure to be here and to talk about something that, of course, many here in the audience, a topic that many here in the audience have been thinking about and working on for years, understanding, the Earth's climate system, making projections of future climate change, studying the impacts of climate change, conveying the threat of climate change to the public and policymakers. So let me go to my first slide here. So, the title of my talk is based on the title of my last book, Our Fragile Moment, which is about the lessons that we can learn from studying Earth's climate past. Lessons that inform our understanding of both the resilience and the fragility of the climate system. The title, Our Fragile Moment, has a certain amount of resonance right now, given everything that's happening in our domestic politics in the United States, in global politics. Certainly, we feel this sort of this fragility of the current moment in sort of the broader sense. But what the book is about is, the fragility of this moment with regard to human-caused climate change, where we are, where we're headed. And when we look at, this is one reconstruction, the hockey stick is just the last little piece of that curve. Other researchers now, decades later, have extended reconstructions of global temperature back in time using more widespread networks of climate proxy data. In this particular study, they use a data assimilation approach using a climate model and combining it with paleoproxy data. But one of the things that's really notable here is that there is this 6,000 year long period, and I've circled it here in red, during which the global climate, at least as measured by global mean surface temperature, there were large regional changes, and you can learn a lot from studying them. But global mean surface temperatures varied very little over a 6,000 year period. So this 6,000 year period is also the period during which human civilization emerged, during which the first large city-states, for example, ancient Mesopotamia came into being. This is when our global civilization came into being, during this period of time that was remarkably steady as far as global temperatures are concerned. And now we are rapidly warming the planet. And so we have 8+ billion people on a planet with a civilizational infrastructure that was created in a climate that is rapidly disappearing. And that is what makes, in a climate sense, this such a fragile moment. And so in the book, I talk about a number of episodes going all the way back to early Earth evolution, a number of very fascinating climate eras and episodes and events that teach us something about, again, this competing sort of resilience and fragility that we see in the climate system. And I'm going to focus just on a couple that are of particular note. Mighty Brontosaurus, don't you have a lesson for us? Does anybody recognize that line from a song by a very popular British band in the 1980s? The Police, Sting, Gordon Sumner, AKA Sting. We'll hear more about him. We will hear from him directly, actually. So what was that song about? The song Walking in Your Footsteps. Of course, we know that there was this event, an asteroid that struck the Earth 66 million years ago, 20 kilometers wide, traveling 10 kilometers per second, struck the planet and created all sorts of mass upheaval and led to the demise of the we used to say the dinosaurs. We have to be careful, the non-avian dinosaurs, because if you look in the sky today, you will see dinosaurs. You'll see birds, which are the direct descendants of dinosaurs. But all of the non-avian dinosaurs, in fact, all megafauna larger than sort of an average-sized dog perished in this event, one of the largest extinction events in human history. So let's listen to the lyrics of this song. People recognize this now? Coming back? I could just listen to the Police the whole time, but we'll just listen to a little snippet here. So if you're like me, if you were a teenager who actually bought the album Synchronicity when it came out in 1984, which I did, and we'll come back to the title of that album because it's actually quite significant here. You probably just thought this was sort of a catchy tune. You probably weren't aware of the fact that this was Sting and the Police communicating to us sort of the gravity of the growing threat of global thermonuclear war and drawing a direct analogy with the KT extinction event that killed off the non-avian dinosaurs. But when you listen to those lyrics as an adult, it's pretty clear that that's the message. And so we'll forgive Sting for getting a few things wrong here in the name of poetic license. It wasn't 55 million years ago. It was 66 million years ago. So that's 11 million years. We'll forgive that small error. Brontosaurus is technically no more, doesn't exist because we now call it a podosaurus because it turns out they were the same species and the name that came first is the one that prevails. And so there is no more brontosaurus. Scientists are fond of taking away things from the public to alienate them, like Brontosaurus. We took that away from the public. We took Pluto away. It's no longer a planet. We're very good at alienating the public. That's one example of it. Now, perhaps more significant, Brontosaurus did not go extinct at the end of the Cretaceous period, at the KT boundary 66 million years ago. It went extinct at the end of the Jurassic period, about 150 million years ago. And if that seems like a small error, you should note that more time has elapsed between then and the KT event than has elapsed since the KT event. In other words, we lived closer in time to T-Rex than Brontosaurus did. Think about that for a moment. It gives you sort of a sense of sort of these profound timescales and how difficult it is for us to really get our heads wrapped around them. What else can we say here? We sort of figured out what had happened back in 1980. The great scientist Luis Alvarez, who many of you may recognize if you saw the film Oppenheimer. How many people here in the room saw the movie Oppenheimer? So Luis Alvarez plays a role, a notable role in the film. He was a member of the Manhattan Project. He was a famous physicist, a Nobel Prize-winning physicist at UC Berkeley. His son, Walter Alvarez, was actually a geoscientist at UC Berkeley. And they collaborated along with a couple other people in analyzing the geological sediments. They found that at 66 million years ago, there was a layer of iridium, which is a very rare metal, a white silvery metal that's not found naturally on Earth. If you see a layer of iridium, it almost had to come from an impactor, from some some sort of extraterrestrial source. And so they realized that this must have been a asteroid impact at 66 million years ago, and inferred, and that's when the dinosaurs killed off an asteroid, killed off the dinosaurs is sort of the logical conclusion of that finding. It turns out that the impact crater itself was not actually found until 10 million years later. It's called Chicxulub. It is in the Yucatan Peninsula, and it was eventually found, the site of that collision. People have modeled what that would have looked like. If you look in the upper left corner here, you'll see this. So the asteroid strikes. This is a model of sort of the seismic response to that strike. So there was global upheaval, massive seismic waves, wildfires, huge amounts of dust, particulates into the atmosphere, into the stratosphere. We'll come back to that. But there was massive upheaval. And one of the most remarkable recent findings is this site Tanis in southern North Dakota. Some years ago, about 5 years ago, no, maybe more like 7 years ago now, a group of paleontologists discovered the remains of essentially what was a seismic flood that was generated into a narrow river valley that dates exactly to the KT boundary. And what they found were the sort of jumbled remains of dinosaurs. There's the skin of a triceratops. There's the leg of another dinosaur. There's the egg of a flying pterosaur still preserved. The embryo still preserved in its egg. There was a small fragment of the asteroid itself found in these remains. It's a remarkable discovery. One of the authors of this, there's Sir David Attenborough, of course, studying these remarkable findings with a microscope. The study presenting this evidence actually includes, as the last author here, the same Walter Alvarez that we heard of before. So the point I want to make here, there was massive upheaval. These sorts of events, we just happened to capture this one. This was happening around North America, Europe, around the world, but that's not what killed off the non-avian dinosaurs or led to the extinction of 68% of all species on the planet. It wasn't the direct impact, the physical impact of that asteroid. It was the atmospheric impact. And a couple years later, a group of scientists, you'll recognize some of the names, Brian Toon, James Pollock, Tom Ackerman, Richard Turco, demonstrated that an event like that would inject enough sort of particulate matter, dust, aerosols into the atmosphere to block out a substantial amount of incoming sunlight. That would reduce photosynthesis, but it would also cool off the planet. And it's consistent with the fact that anything that wasn't small enough to burrow and escape the cold likely perished during this event. So it was the global cooling from the injection of all this particulate matter into the stratosphere that was actually responsible for the mass extinction event that we see. Why is this important? Well, now we get to the great scientist and science communicator Carl Sagan, who comes into the story, because Sagan joined with a number of those authors that we just heard in publishing a year later an article demonstrating that a global thermonuclear war would have essentially the same consequence. And the concept of nuclear winter sort of entered into the public consciousness. Now, this paper came out in December 1983, so this is a couple years later, but now we're seeing this remarkable link. That's the true link here, right? The link between the effect of a global thermonuclear war and the KT event that Sting and the police speak to. The real connection is nuclear winter, and nuclear winter being essentially a counterpart to what actually killed off the dinosaurs. Sagan actually campaigned on nuclear winter, and he went around communicating to the public and policymakers the threat of a nuclear war months before the paper came out. And that generated a little bit of controversy because scientists typically are expected. In fact, I think the embargo policies of the journal Science might in part be a consequence of what had happened in this particular event. Sagan decided it was too important to wait for the paper to appear. And so he did everything he could to communicate this grave finding to the public and policymakers, and literally went on a campaign to alert the world to the threat of nuclear winter, that this is the real threat of the emerging danger of a global thermonuclear war. And you could avoid the direct damage and the radiation from a nuclear strike if you lived far from a population center. The message here was that nobody could avoid the effect of nuclear winter. Analogous to the way the dinosaurs couldn't have, it wasn't the physical damage by that asteroid, it was the global climate impact. So it turns out that even Ronald Reagan was compelled by these findings. That led in part to the politics of détente and treaty between the U.S. and Russia to denuclearize, to demilitarize, to stop building their nuclear arsenals. And so there was a direct consequence, and it's a reminder that actually There was a time when Republican politicians in the United States actually listened to scientists. It's a worthy reminder at a time like this that did happen. What else can we say here? Number of important points here. The dinosaurs had no agency. There was nothing they could do about their plight. Even if they knew it was coming, they couldn't have done anything about it. We don't have that excuse today, right? There is something we can do, whether it's the threat of global thermonuclear war, or arguably the even greater and more pervasive threat now of devastating human-caused climate change. We have agency. That's the difference between us. There are always winners and losers, okay? The dinosaurs were the losers. We were winners in a sense because without dinosaurs, small mammals that would go on to become us were able to occupy niches that weren't available to them when the dinosaurs were around. So now we understand. So the song, Walking in Your Footsteps, it actually was written in December 1982 by Gordon Sumner, Sting, on the Caribbean island of Montserrat. So December 1982, Sting wrote the lyrics to this song. The Sagan sort of campaign to alert the public to the threat of nuclear winter happened October, November, December 1983, almost a year earlier. I assert that the police and Sting were unaware of just how profound the connection between these two events actually was. They wouldn't have been aware of the concept of nuclear winter at the time they drew this analogy, which it turns out is so profound because it is really nuclear winter that ties these things together. So the other interesting thing here to think about is what we're talking about are two events that are causally disconnected. They're disconnected in space and time. There's no causal relationship between the KT impact and the threat of nuclear war and nuclear winter, but they're meaningfully related, aren't they? They're meaningfully related. There's a term, comes from Jungian psychology, for concepts that are not causally connected, but are meaningfully related. Does anyone know what that term is? Synchronicity. What's the title of that album? Maybe there was something deeper going on there. Actually, we'll hear from Sting again, because it turns out he is a deep thinker and continues to be in these areas. All right. Let me just say that, this threat hasn't gone away, right? We're focused on the threat of climate change, human-caused climate change, and we should be, but we should also be aware that the threat of global thermonuclear war has not gone away, especially with sort of the renewed threats from Russia to use tactical nuclear weapons in their war against Ukraine. And we have colleagues like Alan Robach, a good friend of mine, who did some of the original nuclear winter work decades ago and continues to publish work demonstrating that this threat has not gone away. We should be aware of that. Just because we are preoccupied with other threats, this threat still stands today. Let's talk about another episode, sort of at the opposite extreme. Okay, so it was extreme cold that killed off the dinosaurs. And it was extreme warmth that killed off a large number of species during the so-called PETM. Some of the scientists in the room know that stands for the Paleocene-Eocene thermal maximum. It was an event about 10 million years after the KT impact, about 56 million years ago, a very sudden and dramatic warming that led to widespread extinction. And it's sometimes used as the best analogy for a natural rapid warming event. The closest thing we can find in the paleoclimate record to the sort of warming that we're causing today. Now, when I say it's the best analog, it's worth underscoring the fact that warming occurred about 100 times more slowly than the warming that we are causing today. So the best paleo analog we can find to the modern human-caused warming was actually orders of magnitude slower. And remember that next time somebody says, oh, well, living things adapted to these changes. Living things can adapt to changes that take tens of millions of years to happen. It's much more difficult to take to adapt to changes that happen over tens of years. So let's talk about hothouse Earth. And the first thing I'm going to, there's the PETM. It was warming about 4 to 5 degrees Celsius, somewhere in that range. The data are a little uncertain. This is way back in time. But it was a rapid warming in the geological sense that happened about 56 million years ago. You can see the spike there in the record of long-term temperatures. It's a fuzzy but meaningful estimate of long-term temperatures. I'm going to now ask you to consider a spherical cow. There's an old joke, right? Physicists love to come up with very simple models of the world because they're tractable. They lend themselves to analytical solutions. And so we often simplify, in physics, I started out in physics, and you always tried to reduce something to the harmonic oscillator or the particle in the box because you knew how to solve those two problems. So a good friend of mine, John Hart, who's actually an environmental scientist, but a physicist by training at UC Berkeley, wrote this book, Consider a Spherical Cow. But it's sort of a widespread joke about physicists can consider a spherical cow. But I do want you to consider a spherical cow because it's actually useful to consider a spherical cow here. Let's see why. There's our spherical cow. It's not truly spherical. It's got sort of a head. It can move, so there have to be moving mouth parts. But it's as close to a spherical cow as you're going to find, really. So of course, of uniform density, that's really important. All right, so that's a spherical cow. And why is it important to consider that spherical cow? Because we know readily how to calculate its volume and its area. We all remember that from grade school geometry, so we can calculate its surface area to volume ratio, 3 over r. What that tells us is that the surface area to volume ratio of a cow decreases as it gets larger. That's going to be relevant here because the way we cool off is by cooling off through our skin. And our ability to cool off is a function of our surface area to volume ratio. So large organisms in general, it's more difficult for them to cool off than smaller organisms. It's going to be important for what we see in the PETM. Now, I know what the objection is. I can see it in your expressions. Cows are not spherical. We all know cows are not spherical. They're cubic. So fortunately, we can work out the problem. I'm still going to call the side length of the cube r, just to use the same terminology here. We get the same result. The surface area to volume ratio decreases as the cow gets larger. So it's more difficult for a large cow to cool off than a small cow. And it turns out that I leave it as a demonstration for you to show that this holds for an arbitrarily shaped cow. It's a general rule. It's called Bergmann's rule. And one of the things we see during the PETM is a dramatic reduction in size of organisms. There was widespread extinction. We'll get to that in a moment. We were one of the winners. There were a lot of losers. We were the winners because in that environment where miniaturization turned out to be a tremendously helpful adaptation, we get the very first, the very first primate, which is of course our lineage, our mammalian lineage. Dryas, which could fit on the fingertip of your finger. Tiny little mammal. It was the very first primate. It would go on to produce all the other lineages of primates and hominids and hominins and human beings, Homo sapiens. So it was good for us. The PETM was good for human beings. It created selective pressures that produced the very first primate. It was very small. It was well adapted to that environment. Horses shrunk about 30% in size over a time frame of several thousand years. So now if you're a climate contrarian or Tony Blair or someone else, you might say, well, we can all just adapt. That's what happened. Horses got 30% smaller. They adapted to the warmth. But that's not what happened, right? What that means is that there was such selective pressure on miniaturization that there was huge maladaptive pressures on large organisms. Large horses died off in large numbers, and it was the smaller horses that survived. So the next time somebody says, well, you know, human beings will adapt, we'll all adapt, perhaps, but at the expense of millions and millions of unnecessary lost lives when it comes to climate change. That's what we're talking about already, the prospect of millions of lost lives due to the various impacts of climate change. Let me talk a little bit more about the climate implications of the PETM. That's really what I want to talk about here, because it's often held out by climate doomers. We all know climate deniers. You know, I mentioned Tony Blair. There are people who deny, you know, the science or seriousness of climate change, and they argue for climate inaction based on that. And then there are climate doomers, some of whom are convinced that it's too late to do anything. And many of these people are good people. They are, what's so tragic is these are people who would be on the front lines demanding climate action, demanding that our politicians do something if they hadn't become convinced that it's too late. And there are bad actors out there, and I promise you, who are actually fanning the flames of climate doomism, because they realize that that takes people who would be on the front lines and pushes them to the sidelines. They don't care whether you deny that climate change is real or you deny that we can do anything about it. In either case, it supports their agenda of climate inaction. And so doomism can be very harmful, especially when it's premised on a misrepresentation of science. And of course, we're used to climate deniers misrepresenting climate science to argue that climate change isn't real, it's not a problem. But increasingly, we see climate doomers, or at least climate doomers falling prey to misrepresentations of the science that suggest it's too late. And the PETM is one of the classic examples. This is from the movie Before the Flood, from their website, where they talk about the PETM as an example of a massive runaway methane-driven warming event. It led to a widespread extinction. And today, a lot of the climate doomers are convinced that we have triggered runaway methane-driven warming, and it will cause the extinction of our species within 10 years, according to one very popular climate doomer who has a large following. I won't mention his name, Guy McPherson. So this is harmful, right? By the way, I think that claim was made 10 years ago. So I think we're maybe okay. We might be okay. What they say about the PETM, this was a runaway methane-driven warming event. It led to widespread extinction. The same thing is happening today, and it's going to lead to widespread extinction. And it's too late. It's not about the fossil fuels that we're burning. It's about the warming we've already triggered, the bubbling up of the methane and the positive methane feedback that is going to lend to the continued warming of the planet. There's no evidence that that's happening right now. It's possible we could mobilize, permafrost methane given additional levels of warming, but we have isotopic measurements that tell us where methane is coming from. And to the extent that we're seeing increased methane, it seems to be coming from a combination of human activities that are generating methane, livestock and agriculture, and what we call fracking in the US, the extraction of natural gas, which allows natural gas, mostly methane, some of it to leak into the atmosphere. That's where it appears to be coming from. So it's actually us. It's not some natural feedback. But what about the PETM? Is that what happened? Is it, and you see articles, this is only about 2007 Yahoo News, where it's saying, again, PETM is runaway methane-driven warming, and this could be what's happening today. It's a cautionary tale, sort of for doom and despair. Well, a few years ago, some geoscientists actually found the source of the carbon. It timed to 56 million years ago. It was in the North Atlantic, not far from here, somewhere near Iceland, an area known as the North Atlantic Igneous Province, which is a very carbon-rich reservoir of the sort of upper solid Earth. There was a series of volcanic eruptions, a period of intense volcanic activity that tapped into this very carbon-rich reservoir and released all that carbon into the atmosphere. And based on sort of a modeling approach, actually a data assimilation approach once again, they were able to determine isotopically that carbon was almost all in the form of CO2, same greenhouse gas that we are causing to rise today through fossil fuel burning, and methane, as they conclude, organic methane feedbacks of the sort we're talking about, played at most a very small role, no more than 10%. So it wasn't a runaway methane-driven warming scenario. It was a warming caused by CO2, the same CO2 that we are producing from fossil fuel burning today. If anything, it reinforces our understanding of the agency that we have today. The urgency, we've talked about that, but we have agency as well. I'll get back to that. What else can we say here? Well, you know, doom is not helpful. And yes, I am coming for your climate doomism because it's not justified by the science. If the science told us it was too late, as scientists, and I'm looking at some of my colleagues in the room, we would all, that's what we'd be telling the public, because we have to be true to the science, first and foremost. We have an oath, essentially, to do that. But we equally have an oath to say it's not true when the science tells us it's not true, and we know that that untruth is being weaponized by bad actors to convince people it's too late. That net zero is dead, for example, said Tony Blair the other day. You probably saw it in the news. It was actually the same day there was another news article that revealed that Tony Blair had been taking money from Saudi oil companies as a lobbyist. Maybe those things are unrelated. I don't know. So if you don't believe me, if you don't believe what I have to say about the dangers of doomist framing, hopefully you'll listen to our British friend, Gordon Sumner, once again.
Song and the next one, but you're not getting that release, that sense that there is a way out of our crises, and we are in crisis. The world is in crisis. We're in a political crisis. We're in the pandemic crisis. We're in the climate crisis. Music needs to show us a way out, and modern music isn't doing that at the moment.
Oops, sorry, Sting, didn't mean to do that to you.
Song and the next one, but you're not getting that release.
So yeah, music has to, art and climate communication. We have to paint a path forward to the public and not only tell them that we're in crisis. Sting, I think, very adeptly listed the crises that we face, and the climate crisis being foremost among them. But we have to provide a path forward to the public. I think that's critical. So what is that path forward? Let's first of all, before we talk about the future, let's talk a little bit more about the past. Here is a graph some of you may have seen. It is a prediction of CO2 levels in the atmosphere and temperature increases made in 1982. And I see some of my IPCC co-authors in the audience. This prediction is as good as any of your predictions. They got it right, using very simple, sort of almost paper and pencil. Their scientists got it right. No, this isn't the IPCC. It isn't any of our scientist colleagues. This was a prediction made by ExxonMobil, their own scientists, back in 1982. In a report that never saw the light of day, it was buried by ExxonMobil. The team was fired. And let's listen to what their scientists had to say about what the consequences of that warming would be. Not only did they predict the warming that would happen under business as usual, fossil fuel burning, they talked about the consequences. Again, these aren't the words of Al Gore. These aren't my words. These are the words of ExxonMobil's scientists. They warned of potentially catastrophic events if we continued on that course. Sorry. I was going to point out before I do that. So, of course, we know how the story ends. ExxonMobil came forward, warned us about the threat of climate change, did everything they could to decarbonize their business model in some alternative universe that isn't the universe that we live in, because that's not what they did. That's not what other fossil fuel companies did. Instead, they doubled down in a hundreds of millions of dollars campaign to discredit independent scientists who were actually coming to the same conclusion their own scientists had secretly come to, and to discredit the science of climate change and convince the public and policymakers that it was too uncertain to make any policy decisions. And as a result, we are seeing, again, this is exactly as I captured this on my computer screen. This was an article, NBC News, about the devastating consequences of Hurricane Milton, one of these deadly and damaging storms that we've seen more of. We've seen more intense hurricanes, and we know it's tied to ocean warming. And NBC News specifically used that same language, potentially catastrophic. We're seeing those potentially catastrophic events that ExxonMobil scientists warned us of many decades ago. Now, this may be my favorite example of all. Okay, California facing drought crisis again, exactly as I captured it on my computer screen. I promise you, California facing drought crisis as water shortages mount and fire danger escalates. Brought to you by ExxonMobil. Now, that is truth in advertising, folks, even if unintentional. That is truth in advertising. And so as a result, of course, we have the parade of record temperatures that we see every year. If we had acted decades ago, many of you have probably seen some version of this plot. If we had acted decades ago, when the hockey stick was published back in 1999, which is several years after the IPCC had already said with great confidence that there was a discernible human influence on the climate. And in fact, some of our colleagues, like James Hansen, came to that conclusion even earlier, back in the late 1980s. And I think Jim was right. I think we actually could see the impact of humans on the climate even earlier. If we had acted decades ago, back in 2000, you can see how relatively easy it would have been to decarbonize our societal infrastructure to avoid 1.5 Celsius warming of the planet, a level of warming that, as we know, beyond that, we see far worse consequences. It would have been relatively easy, methodical. We could have sort of gently decarbonized our societal infrastructure. But instead, thanks to decades of inaction, because of a misinformation campaign by fossil fuel companies and those promoting their agenda, we have a far more difficult. If you're a skier, what we had before was a bunny slope. I can do a bunny. I'm not a good skier, but I can do a bunny slope. My daughters and my wife are good skiers. They can do black double diamond slopes. And that's what we have now. We've got a black double diamond slope. We've got to bring our carbon emissions down essentially at this point, almost instantaneously, if we are to avert 1.5 Celsius warming. That is the cost of decades of inaction. Now, at the other extreme, and I love the Financial Times, they actually do a great job in general in sort of, in communicating the climate, the threat of the climate crisis. I'm not just saying that because the Financial Times did rank this book one of their leading books of the year of the time it came out. I promise they actually do a great job in informing the business community here in the UK, which is a very refreshing contrast with Rupert Murdoch's Wall Street Journal in the United States, which uses its editorial pages to disinform the business community about the threat of climate change. So they do a great job, but sometimes you have to even call out your friends and know the world isn't warming faster than scientists expected. As I pointed out on Twitter at the time, these are the numbers. And again, many of you in the audience have seen versions of this curve. So the black curve is the average over all of the IPCC models. These are the CMIP6, the most recent IPCC projections under sort of a business as usual fossil fuel scenario. The black is the average over all the models. The blue shading is the range among all the models, because not all the models are exactly the same. They represent processes differently. They have different sensitivities. So there's a range of warming that's predicted by the models, but the average is the black curve. The red is the observations. The models have almost perfectly predicted the warming. They haven't overestimated it. They haven't underestimated it. The models have actually done a remarkably good job predicting the warming. And there's been a lot of talk. Some of my colleagues, James Hansen, has gotten a lot of airtime, claiming that the last couple of years show that the models are not capturing the warming. He's sort of dismissed the IPCC, has said they're hiding this from the public because the public can't take it. I just want you to know, these are the numbers. These really are. The red, you can see at the end of the red curve, that's up through March of this year. Okay, and the black is the average of the models. And I look at that and I find it difficult to get too excited. I say, yeah, there's been some warming above the sort of mean warming line. Yeah, there was a decent sized El Nino from 2023 to 2024, and we know that contributed substantially to the global average warmth. You can see how global temperatures often go below the curve during big La Ninas, extended La Ninas. That's what we saw before this latest warming, and then above the curve during El Ninos. So no, the models have actually done an excellent job. Now we can have a more nuanced conversation. I think I'll have this with some of my colleagues here over here a little bit later today over some of the things that the models aren't necessarily doing very well. And where the models aren't doing very well, invariably, it seems in many cases they're under predicting some of the impacts, not overstating the impacts. So to the critics who say we shouldn't act because of uncertainty, if anything, uncertainty is not our friend because some of the impacts are certainly exceeding what we predicted. I think that's true with respect to ice sheet collapse and sea level rise. I think it's true with respect to extreme weather events. And so there are many things that we might be underestimating, but when it comes to the average warming of the planet, we've done a really good job. Sometimes, the truth is bad enough. This is something that my good friend, mentor, we lost too early in his life, Steve Schneider used to often say this. The truth is bad enough. We don't have to exaggerate it to make the case for urgent climate action because the science alone makes that case if we communicate it accurately, effectively, and honestly. Pierre, my host, Pierre Friedlingston, and his group here, many of you are here in the audience, have done some really important work in helping reframe the discussion because Pierre and others have shown that with the most comprehensive Earth system models we have today, we've learned something really important that we didn't think even 15 years ago. We used to think the planet would continue to warm up. The surface of the planet would continue to warm up when we brought carbon emissions to zero because of the so-called thermal inertia of the oceans. But what Pierre and others have shown is that the ocean chemistry comes into this problem. Oceans absorb CO2 from the atmosphere, and you have to take that into account in any comprehensive Earth modeling framework. And when you do take that into account, to a very good approximation, it appears that the warming stops when carbon emissions reach zero. That means we have a direct and immediate impact on this problem. Our actions today make a real and immediate difference. And that's really important. Yes, you can still stop the worst effects of climate change. As I said in this Live Science article, which was actually an article about it was a popular article, which was about a scientific article that had just been published in Frontiers of Science by Pierre and his colleagues. When we look at the numbers again, we use the best available models. We can ask questions like, what if all the countries of the world meet their obligations under the commitments that were made as of COP26? So if all of the commitments that have been made of all the countries of the world are kept, what does the warming look like? And it comes in potentially below 2 degrees Celsius. We were headed towards close to 4 degrees Celsius at the time of the 2016 Paris summit. Now we're looking potentially at less than 2 degrees Celsius if all the countries meet their obligations. Of course, some caveats there, right? These are promises made, not yet promises kept. This is particularly important with respect to the US that is unilaterally backing out of many of its previous commitments. And 2 degrees Celsius is arguably still too much warming. There will be a lot of damage and destruction and mortality with 2 degrees warming. So we've got a lot of work to do. We've got a long ways to go, but we're making real progress. And that's really important. Again, for the doomers who say, we haven't made any progress at all, we might as well give up. We've made real progress. We just haven't yet made enough progress. We have to be willing to sort of try to keep those two seemingly incompatible notions in our mind. We're seeing leadership. China is today the largest carbon emitter in the world. It's important when people point that out to point out that the United States is the world's largest legacy carbon pollution. And as Pierre and others have shown, the climate system really only cares about your cumulative carbon emissions. So the US has actually contributed more carbon pollution to the warming that we've seen than any other country. And that gives us arguably a special obligation in leading. But in the absence of that leadership, there's some indication that China, which is currently the largest emitter, is sort of stepping up. And there's some hope there. In the EU, the UK, the rest of you are going to have to, for the next few years, sort of up your game as we try to reclaim the rightful role of science in policy in the United States and hopefully turn that errant ship around. We're going to need to make progress in the rest of the world. And you all, I don't have to tell you about the challenges that we're seeing right now in the US. Now, this is my next book. It comes out in September. I started writing this with my friend and colleague Peter Hothouse, who's a leading public health scientist. He's developed vaccines for COVID-19, low-cost vaccines for third world countries. After our friend Tony Fauci, he's the next most vilified public health scientist in the US. Vilified because of the science that he's done. Vilified because he says vaccines work. Vilified because he says masks work. It's a scary time when science are villains. Sometimes we say to our friends in the public health arena, we were dealing with this for decades. So what you're seeing now is sort of is a tried and true sort of tactic that has been deployed against climate scientists for decades. But it's a very scary time in the U.S. Again, we started writing this book more than a year ago, and we thought it was an important book. Then the election happened, and we suddenly realized, all right, well, first of all, we have to rewrite this book, and we don't have much time because we just got the copy edited back, and we had to fundamentally revise. And sadly, and I say this for both Peter and me, we wish this book wasn't nearly as relevant as it's now going to be, but it now feels even more prescient because of the challenges that we see among what we once thought of as the leading democracy of the country. But let's remember, as I like to say, the antidote to doom is doing. Being out there, making a difference, using our voice, using our vote, doing everything we can to put pressure on policymakers, and making sure that we continue to push forward, because the other side is doing everything they can to push backward in the wrong direction. To me, fundamentally, it's about our children and grandchildren. That's my daughter when she was I think 7 years old. She's now, she just finished her first year of college at the University of Pennsylvania. Very proud of her. But to me, it's really about the future of our children and grandchildren. We still have an opportunity to make sure that our legacy could be a degrade and destroyed planet for future generations, but we still have an opportunity to make sure that we leave behind a thriving planet for our children and grandchildren. It's up to us. There's urgency, but there's agency. Thank you very much. Hopefully we have some time for questions. Thanks.
Thank you so much, Mike, for this fantastic journey. There is time for questions, so yeah, you go first.
Yeah. Wearing masks, that's good. Don't. Thanks. I rarely escape without a question about either nuclear or geoengineering, usually both. So I come prepared. And it's, I mentioned Alan Roebuck, and he did some of the really important early modeling that informed our understanding of the threat of nuclear winter. But Alan has also done some of the sort of formative climate modeling on geoengineering early on, before it became as sort of widespread a research theme as it is today. And he wrote he has a nuanced view of this. You can come up with sort of pros and cons, and in the end, it's not the science that's going to decide it. It's a matter of policy, really. It is essential, as Alan has done and others have done. We need to do the modeling to understand whether you're a proponent or an opponent. We need to understand the consequences of these interventions to assess, their value, their efficacy. And so I support, continued modeling efforts to understand the consequences of geoengineering. I certainly support that. I get a little antsy when people start talking about field campaigns. I feel like then we're starting to go down a dangerous slope. One of the things I worry about, I think I would be so bold as to say, I think my good friend Pierre probably agrees with me. One of the things that we worry about is the moral hazard. Like, making this a crutch, geoengineering as a crutch for sort of easing off on our efforts to decarbonize. We've certainly seen some bad actors try to do that. Fossil fuel interests. Famously, Rex Tillerson, who was the CEO of ExxonMobil before he became Donald Trump's Secretary of State in his first term, once famously said, climate change is just an engineering problem. So there is an effort to sort of weaponize geoengineering to take the pressure off of decarbonization. We have to make sure that we don't allow it to be framed in that way as well. But other than that, I think there's a good faith conversation to be had about that. I have the sense I might be having one of those conversations later this evening. Thanks for the question.
Outside of the government in the US, is there still a good degree of optimism for the next 4 years, 5 years to come?
Yeah, it's a great question. As I like to say, the obstacles at this point are not yet physical. They're not climate physics. The models tell us it's still doable, right? They're not technological. We have the technology now to decarbonize our world. It's a matter of having the right incentives in place. So the obstacles aren't they're not physical, they're not technological, they are political. And political obstacles can be overcome. That having been said, we have one of the greatest political obstacles we've ever encountered now, in that the United States has literally been weaponized by bad petrostate actors like Russia and Saudi Arabia and the fossil fuel industry to be a cudgel opposing any meaningful progress on climate in the years ahead. If we can limit that, to maybe even a year, if Democrats reclaim Congress, we could block sort of some of that agenda, and then 3 years from now, 3.5 years from now, we have a new president. We could start to reverse those policies. The good news is that the United States is responsible now for a fairly small fraction of global carbon emissions, and our carbon emissions have been coming down and probably will even under Trump, despite all of his rhetoric about coal. He can't change the laws of economics, and coal is not economical right now in the United States. It's not going to be. We're not going to see a rebirth of coal, despite him sort of trying to placate some of his fossil fuel supporters by using rhetoric to that effect. So the U.S. carbon emissions will probably continue to go down over the next couple of years. It's not, and it's a small enough fraction of global emissions that is going to depend on what the rest of the world does in these years ahead. We have the largest legacy contribution to carbon pollution, but going forward, it's going to be about India. It's going to be about China. That's where I become concerned that the United States, in easing off of its commitments, that provides an excuse to the Indias and Chinas to ease off in their own efforts. And to that extent, I'm buoyed. I'm encouraged by some of what we've heard from China lately, that actually they see this as an opportunity to assert their leadership in the defining challenge of our time. And maybe there's some PR reasons for them to want to do that, but I think at the same time, there's some earnesty there as well. So I remain cautiously optimistic that we can get through this. I don't see any way forward if we allow sort of the anti-democratic forces that have been making huge gains in the US and around the world. If they are victorious, I don't see any path toward meaningful global climate action or to solutions of any of the great crises that we face that doesn't go through global democratic governance. And so I think the most important thing that we can do is to preserve democracy, because without it, we have no ability to tackle these problems.
Question, when we talk about climate change and issue carbon mainly we talk about US, China, but based on several data, I'm from Indonesia, and based on here, like I said, we need substation artificially growing effectively. Industry also shifting. Production in China is not cheap anymore, and they start to make Vietnam.
Yeah.
Indonesia, I think, last depression and depression is different.
Yeah.
So I start to have a really bad, I'm worried actually. Let's say US and China say that, well, we can achieve the net zero, but then another part of the world, like South Asia or maybe Africa,
Yeah. Absolutely.
And I just wonder that what's your view? Is something that maybe happening?
Great question. And we see the fossil fuel giants going into Africa and lobbying heavily. They want to commit the developing world to fossil fuel infrastructure. They want to create power grids that will be dependent on fossil fuel infrastructure. And they're working hard now to do that. in places like Africa, because they realize that that is the growth potential for them in the future. That's where they're going to see growth. And so we have to be pushing back on that heavily. And to those who like to say, oh, well, and you see people like Bjorn Lomborg, who claims to be a skeptical environmentalist. He's neither. True skeptic, doesn't argue against the overwhelming evidence based on the flimsiest of arguments. That's not scientific skepticism. It's some that try to sort of seize the mantle of skeptic. So people like Bjorn Lomborg, who sort of, they are sort of, proponents of the fossil fuel industry. They sort of promote fossil fuel industry friendly propaganda in the op-eds that they read. He's said, well, the best way we can help the poor is by providing them cheap energy in the form of fossil fuel energy. And that's not true. The poor countries of the world are seeing the worst consequences of climate change now. They have the least resilience, the least wealth to insulate themselves against the devastating consequences. Low-lying island nations that are already being inundated. So those who had the least role in creating this problem in the first place are actually experiencing the worst consequences. And it's deeply immoral for fossil fuel interests and those promoting their agenda to go into those countries and try to convince them that it's in their interest to commit themselves to a fossil fuel future, when it makes much more sense at this point to build clean, distributed energy infrastructure. So that is where the debate, that is a very important sort of front right now in this assault on our climate future, is an effort to commit developing countries to, fossil fuel infrastructure. There's a question right up here. Yes. It's a good question. And I had written a number of books like A Hockey Stick in the Climate Wars and The New Climate War and The Tantrum That Saved the World, which was a fun book. I wrote that with a children's author and illustrator. It actually came out a couple years before Greta Thunberg appeared on the scene. And yet it is about a young girl who becomes distraught about the climate crisis and goes on this empowering journey to change the world. So I'd written a number of books like that, but, I had never written a book about paleoclimate, which seemed a little odd because it sort of got my start scientifically in the field of paleoclimate. So I sort of decided, let me write a book about paleoclimate, but I needed to broaden my knowledge. I mean, the hockey stick is only about the common era, the last 2,000 years. There's a lot more Earth history than that, and there's a lot to learn from it. And so I sort of committed myself to learning, the lessons that we really can from the entirety of Earth history when it comes to the climate crisis. And also in part because I was seeing, as I've alluded to in this talk, the sort of weaponization of doomism by people misrepresenting the paleoclimate past, misrepresenting the end Permian extinction or the PETM as if they tell us that we are doomed to civilization, extinction generating climate change no matter what. I was seeing paleoclimate, I used to see it misrepresented by climate deniers. They loved the idea of a global medieval warm period that was warmer than today. The data doesn't support that because it suggested that maybe natural variability can explain it. But what I was really disturbed by was the way that paleoclimate was now being weaponized by bad actors to purvey doom and despair. And so I wanted to reclaim the record and what the science has to say for its rightful role in this conversation. And I would say that was fundamentally what drove me to write this book. And now I'm returning sort of to politics again with Science Under Siege. Hey, Mark. Yeah.
I have a hypothetical question about the U.S. government, particularly the power that we've seen the U.S. president during the President Trump. And my question is, if President Trump, given all the power he has, all the tools he has, all the political ability, suddenly had a change of heart, or perhaps there were a different president, and you were brought in to be the scientific advisor what would you advise the president to do?
Thanks.
And how much of an impact would it have globally if the U.S. was?
Thanks. It's a great question. I think the first thing I would do if Donald Trump gave me that opportunity, I would invite him here to the Cliffs of Dover.
He's changed his.
Understood, and I just couldn't not get that in. I would love for that to be the case. I would love to see the return of sort of good faith conservatives when it comes to the issues of sustainability and climate. I actually befriended the former Prime Minister of Australia, Malcolm Turnbull, when I was visiting Australia. I happened to do a sabbatical there during the Black Summer. I arrived for sort of the defining climate catastrophe in Australia's history. But I got to know a number of interesting folks there. And Malcolm Turnbull was one of them. And he's a great example of, a good faith conservative. He has conservative principles, but if you're true to conservative principles, and I think Maggie Thatcher was a good example of that as well. These sort of old school conservatives who were consistent in their philosophy. If you're truly a conservative, surely conserving the planet, conserving, our future should be part of your ideology. And there are some conservatives like that in the U.S. And I would love to see the party perhaps reform. One possibility is like the phoenix, that goes up in flames and something new it forms in its place. If the Republican Party collapses under the weight of Donald Trump, and there's a real possibility of that now with the fiscal policies that he's pursuing. He's alienating the business community with this threat of tariffs. If sort of Trumpism collapses, there's an opportunity for those who've been waiting in the wings of the Republican Party that don't want to be on the wrong side of science. They don't want to be on the wrong side of our future. They may have conservative principles, but they have principles. I hope that we might see an opportunity for the reemergence of sort of the old school Republican Party, the Republican Party that had a Richard Nixon that created the EPA to deal with water and air pollution, a Ronald Reagan, who, as we saw, played an important role in nuclear de-escalation ultimately, but he also supported the Montreal Protocol to ban ozone depleting chlorofluorocarbons. George Bush Sr., who supported the Clean Air Acts. So there used to be, and I could go into when I was under attack by a Republican Congressman, Joe Barton, some years ago. He was the chair of the Energy and Commerce Committee, the largest recipient of fossil fuel money in the U.S. Congress, who went after me and my colleagues. Two of the first people to step up and defend us against this assault by a Republican committee chair were John McCain, who was one of those old school, good faith Republicans, and Sherwood Boehlert, who was the chair of the House Science Committee. This was in 2005. Republicans had full control of Congress and the presidency. Joe Barton, there was really nothing to stop him if Republicans hadn't come up and opposed him. Sherwood Boehlert was the chair of the House Science Committee. He was from a district, in New York State that is home to the Appalachian Mountains. He played an important role in the Clean Air Acts himself. He was an old school pro-science, pro-environment Republican, and he came to our defense, as did John McCain. I hope that there's an opportunity that reemerges for those sort of individuals who are waiting in the wings to reclaim their party, because I think there's room for a good faith debate about the policy solutions that we invoke to deal with the climate crisis. And there's a role for people with conservative principles and progressive principles at the table, as long as they come to the table in good faith. And that's what I would like to see reemerge. Good time for one more? No? Oh,
Yes,
yep.
one more. Thank you.
Thank you for the talk. You mentioned most of the efforts now should be to sort of democracy, and under climate stability and some globally, is there a way that you're question, but in your thoughts, but for more aggressive efforts, or citizen-led initiatives that are not
Yeah, thanks so much for that question. I get the sense maybe you're an American, so you have a horse in the race like I do here, and we all do. We all do. What happens in the U.S. Is going to have implications for the rest of the world. So I think grassroots organizing is an important part. I mean, it creates the pressure, it creates the space. There's been an interesting debate about some of the tactics. It was like Just Stop Oil and the oil, the Van Gogh, soup incident. And we can have a conversation about what tactics make the most sense. But I do think that sort of grassroots organizing and pressure is critical because ultimately that's what forces the hand of politicians in the end. I can say that in terms of our university politics, and I now occupy a new role. I'm the vice provost for climate at the University of Pennsylvania. So trying to coordinate everything we do on climate. And part of why this position was even created was because students were demanding that the administration do more on climate. They'd like to see Penn divest of fossil fuel holdings. That hasn't happened yet. But short of that, they certainly were demanding that the university do more. And so that was a good example of where grassroots organizing really made a difference. One more example, I know this is going to drag on a little bit, but when I was an undergraduate at UC Berkeley in the 1980s, mid-1980s, I came there in 84. Ronald Reagan was reelected president that fall. UC Berkeley, which was this sort of historically this font of activism, had sort of gone conservative. And there was very little activism on campus. And then within a couple of years, there was a new movement that was emerging. And there were demonstrations in Sproul Plaza demanding that the administration, the UC regents, divest of their holdings in the South African government that supported apartheid. And UC Berkeley gave into that pressure. That began a nationwide movement of divestment against South Africa for their apartheid policies. And within a couple of years, the apartheid government had collapsed. I like to think that was an example of student activism, even at the university that I was attending, changing the world for the better. And so we see something similar with climate today, where a lot of the passion and energy is among young folks who become disillusioned, I would say, a little bit with the COP process, understandably. And I think that's good. I think their feet need to be held to the fire. I personally don't think that COP should be held in petrostate countries every year as opportunities for their operatives to strike deals with fossil fuel companies. That is not a good look because it's not good. And in part, it's the Greta Thunbergs and the youth climate movement holding people accountable. I think that's absolutely critical.
Right.
Okay.
Thank you again.
Thank you.
I'd like you to join me.
Thank you. Thanks.